Hey everyone, hope you're doing well. These notes are going to be over the third method for solving a 2x2 system of equations, and that is the elimination method. So we're going to start with this warm-up, all right? This warm-up says to rewrite this equation into standard form. The reason that this is beneficial is because you kind of want them to be in standard form to do elimination method. And so in order to do that, so if you remember, standard form is ax plus by equals c. So we need to get x and y on the same side. And so by bringing that x over, we have negative 3/2 x plus y equals -1. And then we want to get rid of the fraction, right? Because we just want there to be just a number in front of x. I mean, this is a number, but we kind of want to get rid of that. So we want to get rid of that fraction, and we can also get rid of that negative sign at the same time too. So this is kind of similar to what we've done in the past, right? And that's just to multiply everything by -2 on both sides. And by doing that, we'll cancel this out, we'll cancel this out, so that'll give us 3x. And then we're multiplying, -2 times y. So that's 3x minus 2y equals 2, okay? And that would be in standard form. So some of these questions you do have to turn it into standard form. I mean, once we get good, right, you'll know like, okay, they're in standard form, let's use elimination, or no, they're not in standard form, let's use substitution, right? But we're just kind of showing you both ways so you can see what you like right now. So these are the steps for solving by elimination. I'm not going to go through all of these examples, mostly just the ones on the left. You guys can try the ones on the right on your own. But there's basically like progressing difficulties here. So the first thing you want to do is line up your equation. So that's, getting them in standard form, getting both the x and the y on the same side, right? And getting them lined up underneath each other. So I'm going to subtract that over, and that's going to give me -x plus y equals 7. All right. Now, my top equation, I'm going to rewrite that because you want the equations to be like right over top of each other, okay? And here is the whole purpose and reasoning behind the elimination method, okay? Number 2, we're not going to do number 2 on this problem. We'll do that on the later ones. Step 3, all right, you're going to add the equations to eliminate a variable, okay? You want one of your variables to cancel, right? So in order to cancel, it has to be same number, different sign, right? So x minus x, if we add these equations together, x minus x is 0x. So this goes away. 7y plus y is 8y, and 17 plus 7 equals 24, okay? So now where we went from, okay, we have equations with 2 variables we can't solve. Now we have an equation with 1 variable, and this is easy to solve. Just divide by 8, and you get y equals 3, okay? So once you have that, now we're on step 5, right? This is the same last step as in substitution. You're just going to substitute your answer from step 4 into either equation to find the other variable. So you don't really have one that's like solved perfectly for you. But you just want to plug it into either equation that you want. So I'm going to plug it in for right here, I guess. So that's going to be 3 equals x plus 7. And then I'm going to subtract 7 on both sides. And so that gives me x equals -4, right? So my answer is -4, 3, okay? And that's pretty much what you're doing here for the elimination method. So that's kind of the easiest one. That's one where things cancel already. We're going to look at a different one right here, okay? This one's similar to the last one in the sense that we need to get it lined up first, right? And lined up doesn't just mean that you need x and y to be over top of each other. You also need the equal sign to be in the right place, okay? So there's my new bottom equation. I'm going to move this top equation down. So this is, slightly more difficult than the first one because if we look at this, nothing cancels here, right? If we add these together, nothing's going to happen. So this is where step 2 comes into play. If needed, you need to multiply one or both equations by a number, all right? So that then something will cancel, okay? So right now, nothing will cancel. X plus 4x is 5x, 5y minus 9y is negative 4y. So what do we want to do? We need to multiply. And you want to basically get two of your variables to have same number, different signs. Now, we have an x and a y here. If I look at the y, I've got 5 and 9. Am I going to be able to multiply 5 by a number that's going to equal 9? No, okay? So y isn't a good variable to pick here. X, however, is a good variable to pick. It's always good to pick a variable when there's no number out in front because that means its coefficient is 1, which means you can multiply it to make any number. So we need to make it we need to make it cancel out with 4. So we need to multiply this by negative 4, all right? Not just 4, because 4 plus 4 is going to make 8. We want to do negative 4 so that negative 4 plus 4 equals 0. So we're going to multiply the whole top equation by negative 4, and that means all the numbers, even on the other side, all right? So it's going to give me negative 4x, then negative 4 times 5y, that makes negative 20y, and then negative 4 times 4 equals negative 16. Okay, so if we add these together, 4 minus 4, that cancels, negative 9y minus 20y, that's negative 29y. Negative 42 minus 16, that's negative 58. Now I divide by negative 29. And you're always going to just have one step of solving because it should always just be to divide by something. And that's going to equal 2. So now I've got y equals 2. Again, now I can plug it back in. I'm going to plug it in here. Right? That looks a little bit easier. The x is already by itself there. So this is going to be 4 minus 5 times 2. And that's going to be 4 minus 10, which equals negative 6, okay? And that's x. So my answer is negative 6, comma 2. All right, so this is what you need to do if you need to multiply one of your equations. So 4 is similar, right? You just need to multiply one of your equations by a number. Oh, I haven't been writing my solutions right here. I forgot about that. Okay. We're going to do one last one because these ones on the bottom are just kind of for extra practice for the kids in class. You can try them. This is when, they're already lined up. This is when you don't really have anything good to multiply by, right? If I'm looking at x, I've got 3 and 4. 3 is not going to multiply by anything to get 4. We've got 9 and 12. 9 is not going to multiply by anything to get 12, okay? So if you get this situation, you have to multiply twice, all right? Yes, you have to multiply twice. So you have to multiply both equations by something. So 3 and 4. So we need 3 and 4 to go to the same number, all right? The smallest number of 3 and 4 both go to is going to be 12. So I need to multiply this by 4, and I need to multiply this by 3, right? So they both equal 12. Now I need one of them to be negative if they're going to cancel. So I'm going to add that negative sign at the bottom. All right, you could add the negative sign at the top. It doesn't matter. But we're going to do this. So we're going to distribute here, right? Triple distributing to everything in the whole equation, even the number on the other side. So we got 4 times 3, that's 12x. 4 times negative 9, that's negative 36y. 4 times 9, that's 36. Then we can move on to the bottom. This is going to make negative 12x, so these are going to cancel. That's what we wanted. Negative 3 times negative 12, that's plus 36y. And then we've got negative 3 times 36. Ooh. What is that, 108? Negative 108? So this is actually interesting. I'm glad that we did this problem because this will be one of those special cases that we talked about, okay? What's 12x minus 12x? Cancel. Negative 36 plus 36. Cancel. I got 0 over here. Now, do I get 0 on the other side? No. 36 minus 108 is not 0. It's 72. I hope it's 72. All right, so we've got 0 equals 72. So we got our special cases. Now we got to figure out which one this is. Is this true? No, this is not true. 0 does not equal 72. So this is actually no solutions. Just like with substitution, okay, if you did get the same number on both sides, that would be infinite solutions, but we didn't, so we got no solutions. So those are pretty much the 3 situations, all right, that we've got to deal with, okay? So the other problems, you know, that right next to it are similar. You know, here they'll cancel right away. Here you got to multiply once. Here you got to multiply twice. So I want you guys to, you know, try some of these other ones. You've got a very small practice to do as well. If you have any questions or you want to ask me about any of these other questions, you can. Other than that, have a great day.